Something else that I wanted to show you is that the way you represent that collision geometry as animated or as deforming not only influence how that volume is created, but also how constraints behave when you have geometry that is interacting with each other. So in this case I have this very simple example where one tube is constrained to this box, and if I press play I have this very interesting behavior where we have a deforming tube. We have a static geometry as the box that it's only working as collision, but also the tube is constrained to the box. So in order to explain you this better, rather than showing you node by node, we're gonna do this from scratch very quickly. I'm gonna create one node called constraints and bullet properties. Let's dive inside. Let's create one box. Let's put a transform after the box. Let's change the scale a little bit. Let's set its name with a primitive wrangle. And the name can be anything you want as long as it's consistent. Now let's create an RBD configure. By this point you should know what this do. And let's create a transform. What I'm gonna do with this transform is basically animate this box so it does something and it is not always on the center. So let's put a few keyframes here and there. So there you go, this is what we have. Let's make this a little bit faster. And now we have the ground collider. Let's create the primitive wrangle, the point wrangle, that is going to set the point attributes for bullet. I want this geometry to not be active, but I want it to be animated. And deforming it's gonna be 0 because I want the transform to be used rather than rebuilding the shape of the box on every frame. Now we're going to create the tube. Let's set the height to 7.56 and that's all we need. Now let's use a match size. And it seems like we have a viewport problem, so what I'm going to do is close this viewport and open a new one. Okay, so I want to put the tube on top of the box. So the first thing I'm going to try is to use a match size, set the justify Y to minimum, and then I'm gonna copy the height of this box. So I know the height is 1 or the scale is 1, so I just need to add the half of that to a transform. So now we have the tube on top of the box. I want to fracture the tube, so let's create a scatter. Let's reduce the amount of points to 10 and let's create a Voronoi fracture. I want to change the piece prefix so it uses a different name. Let's call this tube. The next thing we need is another RBD configure, so I'm just gonna copy this one. And I also want to set the point attributes for bullet. In the case of the tube, I actually want it to be active and I don't want the animation to be used. So we have an animated box and we have a tube that is staying on the center. I'm going to merge them. I want to double check that they are actually packed, and then all I need to do is create a DOP network. Let's do our usual stuff, an RBD packed object, a multiple solver, a rigid body solver, and let's not use gravity in this case. Let's change the name to RBD. I want to keep this as it is. I need to change this to first context geometry, so we bring the geometry in the first input, and I want to override active and animated and deforming by whatever comes from subs. So now we have something that is failing, and I'm pretty sure I made a mistake, so let's have a look. So you can see that deforming is set to 1, I need to set it to 0, so the animation is used. So now you can see it's working. But the next thing I want to do is constrain this tube to the actual ground. So let's do that. In order to do this, I need to use constraints, and remember what I said at the beginning, this is not a tutorial about constraints. So I'm just gonna assume that you already know how to use them. I want to create a group of constraints for the tube only. So let's have a look here at the Voronoi fracture. And I want to create a constraint between each one of these pieces. So I'm gonna use a connect adjacent pieces. This is gonna create these primitives. And I want to change the parameter of connection type to adjacent pieces from surface points. Now I want to create twist constraints. And in order to have twist constraints, I want to reduce the length of each one of these primitives. So I'm gonna create a facet. Then I'm gonna make sure that unique points is set to on. So we split these points, so each primitive is separated from each other. So I'm gonna create after that a primitive sub. I'm gonna set do transformation. I'm gonna set the scale to 0. So now you can see that all this is doing is scaling those primitives. So they are now in the center of the primitive. Of the original primitive basically. If you don't use this facet, what's going to happen is that this transformation won't work because they are not independent primitives. So make sure you have this on before. Let's bring this back to 0. And now I need the attributes that the constraints need to work. So let's create a primitive wrangle. Constraint properties. And it needs a few attributes to work. So the first one, it's going to be constraint name. And I'm going to set the constraint to twist. The other one is the constraint type. And I'm gonna set the constraint to all, so it also affects position and rotation. And the last thing I want to tell Bullet is that the rest length of these primitives is 0, otherwise it's gonna use 1. So I want to set a rest length attribute of 0. Let's bring this into dubs. Let's create a constraint network. Let's plug it here, so the object goes into the object, and then we need to create the constraints. And the first constraint we created above was the twist constraint. So I need to create a twist constraint relationship. Let's connect this into the second input. And now we have everything we need. Lastly, we need to set the geometry source to second context geometry. So it brings the constraints that we put here. Make sure that this is set correctly. As you can see here, I made a mistake with the T. And this name here needs to be the same as the name that we have here in the constraint, in the actual constraint node. So let's go down and change the data name to twist. So now you can see the constraints are actually showing up here. I'm not going to take care of the rotations or the orientations of these constraints. I'm going to use them as they come by default. The only thing I'm going to do is change the max up rotation and max out rotation to 20. So if I press play now, what's going to happen is that you can see that the tube remains together. But I want to constrain the tube to the box. So let's create a merge where we bring back the box and the tube. And now we need to find a way to create constraints only between the box and the tube. I want to basically constrain these two pieces. Let's create a connect adjacent pieces. Let's set this back to the same parameter that we used before, adjacent pieces from surface points. And what's happening is that you can see now that there's one constraint that goes all the way to the center of the box, but we also have constraints inside the tube. I only want to have this constraint here. We could delete every single constraint that is not this one, but I'm gonna do something that is more procedural. There is this parameter here called find boundary connections. And we can create one attribute to make sure that this node knows what is the ground and what is the tube. So I'm gonna also create a primitive wrangle that I'm gonna call part. I'll plug it after the name, although it can be before, it doesn't really matter. And I'm gonna create a string attribute called part. It can be also anything you want. I'm gonna call this one ground. And I'm gonna copy this part after the Voronoi fracture. And I'm gonna set the part to tube. Now you need to make sure that both geometries before they get into the merge have the part attribute set. So let's reconnect this. So rather than going from the Voronoi to the merge, it's going from the part wrangle to the merge. And now that you have that, in this find boundary connections, you only need to set the cluster attribute to part. And as you can see, it's creating constraints only between the two pieces that have a different part attribute. Now we need to do the same exact thing that we did before, because I want these constraints to be twist constraints. So I'm just gonna create another facet. Make unique points. Let's create the primitive. Let's do the transformation and set this to 0. And we need to set the same primitive attributes for this constraint. So let's select this one that we made before, Ctrl C, Ctrl V, because it's exactly the same. So now we can merge these two constraints, so they go into Bullet. Let's create a merge. Now we have the constraints for both the ground to the tube and the tube only. Let's go back into the dub network. And now you can see that the tube is following the ground, but also those constraints are working for the tube. So now I want to show you why I did this. So if you go to the point wrangle where we set the attributes of the tube for Bullet, and you change deforming to 1 and animate it to 0, because Bullet is gonna rebuild the deforming volume, it doesn't know anything about the transform. And what's gonna happen is that those constraints are going to stop working. So you can see that the tube tries to remain in the center. And that's because it doesn't know how to transform those constraints. So let's bring this back to animated and deforming set to 0. And now you can see it's back working. The reason I made this example is because I want to give you ideas. And you can use this for car collisions or metal deformation or things like that. I have used this approach many times. So I put together an example on the right that describes the same thing, but it's used in a different way. So you can see my super model of a car colliding with this wall. And if I press play,